Hey everyone and welcome to a new video. In this video, I'm going to talk to you about how system calls work in Linux. The setup is a bit different. I got my iPad here and I'm going to walk you through how system calls work in Linux and what kind of different modes it's active in, how does the Linux actually make system calls, and at the end we're going to look at an example of how an actual system call is made in C and how it's how do we actually how does it work under the hood. So let's get straight into it. Okay. Okay. So let's break it down into what we actually think happens when a Linux kernel makes a system call. Okay. So let's begin. So let me change the pen here. Okay. How system. Let me just mute that. That's not required. How system calls work. Okay. So one of the first important things that you got to remember when you're dealing with system calls is why do you need to worry about system calls, right? So what happens is you got to remember that whenever you're executing a program in Linux, not every single execution happens in or around the program space, right? The Linux kernel is divided into two major spaces. The first space is called as the user space, and the second space is called as the kernel space, right? Most of the functions that we execute are usually in this space called as the user space. However, during this execution, there are some cases when we want to execute certain functions inside the kernel space that is different from what is taking place in the user space because it needs certain extra privileges to be able to access certain memory locations, certain places in hardware, certain buffers, certain registers which are not available in the user space. All of those things actually happen in something called as the kernel space, right? Now, the first important thing that this is the prerequisite to understand how system calls work in Linux, right? First, let's understand the differences between these two spaces, right? Now, the first thing is this is usually where applications run, right? Your normal applications, whenever you execute any application, it usually runs in the user space, right? Whenever we're talking about the kernel space, we're talking about certain operations like reading files, reading memory, being going deep into reading buffers, reading registries, etc., etc. That is only related to the operating system working. So that is the kernel space, right? Why do we need to split them? Because no single application could, you would not want any application to cross this boundary that exists here between these two spaces. Why? Because there is sensitive data on this side, right? You would not want a program that is running on this side to come in and say, hey kernel, I want to read all of the confidential memory spaces and maybe corrupt them, right? Any sort of program that might have certain data corruptions or that might have certain errors could corrupt this buffer here on this side, right? And so we would want to have that space between the kernel and the user space, right? Also, you would want, like, it has additional securities, right? During your program might want to access certain areas of memory which we do not want a normal program to kind of like touch. That's why you usually have these kind of like differences, right? um, so with this is your prerequisite, right? What I just explained to you is a prerequisite. You need to understand that there are two spaces. One is the user space, one is the kernel space. There is a boundary between these two spaces, and usually your programs run in the user space whenever they want to execute certain actions or certain operations that are a little bit more privileged, that require access to certain parts of the memory or require access to certain functions of the operating system that need to be abstracted away from this boundary for security reasons. That's when you usually have the transition between the user space and the kernel space. Okay, with that prerequisite in mind, let's dive deep into what is a system call, right? What is a system call? Now, we'll work on this with a sort of an example. Usually, say for example, you're trying to open a file, right? You try to open a file in your Python program, right? This is your Python program. And inside that, you call something as, say, you write something like um, open or with a something open, right? And then you do something like this, right? And open, and then you provide the file name. Now, this Python program, as I explained earlier, is running in something called as the user space. So this is your user space, right? And inside this, you have your Python file. Now, your Python file makes a call to open, right? What happens when it makes a call to open? The first thing that happens is it has to transition between the boundaries of the kernel space and the user space, right? So it does something called as an interrupt. We'll not get into what an interrupt means in this video, but all that you need to remember is that whenever it wants to make a certain call to us, when it wants to make a call to the kernel, what the CPU does is it sends an interrupt. It says, hey, user space, I now want to execute something that I need kernel level privileges for. Now, in this case, what you need to understand is the open function is internally, it makes an internal call to something called as the open function that's defined in the open file that's defined in the C library, right? Because C is the ground level API that is used to communicate between your function, your machine and your assembly, right? You have your machine here, and you have your assembly level code that has all the registers here. The boundary between that is usually the C API in which all of the function calls are written. Okay. Now, with that information in mind, what happens is it switches from, now that we have discussed this, it switches from your user to the kernel, right? After sending a interrupt, right? Now, once you are on the other side of the kernel, now what happens is this is where the actual system calls happen, right? So in order to understand this, what I need to explain to you is, so inside the kernel or inside the system, you have the procedure call for syscall, right? Syscall is what happens, right? Now, what is syscall, right? Syscall is the actual assembly level instruction that is called when you execute a system call. What it says is, hey kernel, go look at where your procedures are defined, and once you know where a syscall is, usually it will have a syscall number that it calls, right? That's the execution. It'll say, hey user, hey kernel, this is your syscall. Can you go to that particular place in memory where the instructions for syscall are written and go ahead and execute this line by line, right? Once it executes this line by line, as in open the file, put in all of the buffers or set all the privileges, etc., etc., I want you to return back to the kernel, right? This is the high level architecture of what happens, right? High level architecture, right? In order to understand what actually happens when you call, there are certain steps that happen, okay? So the first one is, as I mentioned, when you call in open, what happens is there are four things that happen. First is it goes and says, hey, transfer all of the data, right? Transfer all of the data to wherever you require in your specific registers, and ensure that all of the file name, etc., is put in the correct register. You have the correct number of the system call, etc., etc. You give or you don't give, you actually check. Let me rub this out. So what you do is you actually check if your program has all of the privileges that it requires, right? Okay, that's what it checks. Once it knows that it has all of the privileges, it will then go ahead and execute that particular system call. That is, go ahead and execute the syscall that you need, and do the operation. That is the most important part. Like, do the operation, and once you're done with the operation, I want you to return the value, right? Now, these are the four things that happen when you do a system call, right? These are the four steps that happen, right? Now, this is what happens when in all of the system calls in Linux. These are the four steps: transfer all of your data, check if your program has all of the privileges, execute the system call, do the operation, and then return the value. And the prerequisite is this happens only in the kernel mode. That is the only thing that you have to remember. Once the kernel mode execution is done, it will say, hey program, here, go back, transfer to the user mode and continue the execution of the program. Okay. Now, after I explained to you all of this, one of the most important things that you need to remember is why can't this all of this be done in the same mode, right? The question that arises is, hey Sladen, you explained all of these system calls, but why can't a system call be executed in something called as the user mode, right? It's very important to remember this, that for executing system calls, you need certain access to memory. So many processes inside the kernel, right? Inside the kernel, they share they share process IDs, or there are forks in the kernel. There are certain areas of memory that are shared. There are file descriptor tables. There are also like interrupts, etc., defined in the kernel space, right? You wouldn't want a normal program to come in and access any of this or disturb the functioning of any of this or corrupt it, right? So that's why we have a clear distinction between these two process modes, right? The kernel mode and the user mode. And always remember that when anything is executed in the kernel mode, it has certain set of privileges, and these are the set of privileges that it uses to kind of determine what is important in that particular aspect, right? Now, just before I let you go, one of the whenever were dealing with some sort of a system call, what you have to remember is inside in a C, I'll probably explain this in another video. What happens is it does, or in modern CPUs, it calls something called as a write, and then you have the syscall here that is, say, for example, open file, you pass in the buffer, you pass in the buffer, you pass in a sort of the place where you want to write it, or the return code, and then this is sort of a high level way of how it works. And once C makes this call, it just returns a return value to the return. We check that and then we execute it. This is how you would implement a system call if you wouldn't want any of the abstractions. But yeah, just to summarize before I let you go, what we learned today was, what is a user mode? What is a kernel mode? What are the differences between them? Why can't you have all of the functions or all of the programs running in the kernel mode? We then looked at privileges. What kind of privileges do we have in the kernel mode? What kind of privileges do we have in the user mode? And then we saw an example of what are the 4 operations that are executed every time a syscall is made. And what kind of procedures does it follow? How does it return? And all of that stuff. What we didn't talk about in this video that we might talk about in a separate video is interrupts. When it transfers from the user mode to the kernel mode, it sends a sort of interrupt through, right? Now that interrupt is what says, hey kernel, I've sent an interrupt, can you stop execution and deal with this, what I'm talking to you right now. So yeah, that's all that we covered in this video. I hope you liked the video, and I will see you in a next video. Till then, goodbye.